Good morning and welcome to the first in-person meeting of the National Transportation Safety Board since February of 2020. I'm Jennifer Homendy and I'm honored to serve as chair of the NTSB, and joining us are my colleagues on the board, Vice Chairman Bruce Landsberg, Member Michael Graham, and Member Tom Chapman. Today, we meet in open session as required by the Government in the Sunshine Act to consider the draft final report of the Air Tour helicopter accident that occurred on December 26, 2019, near Kekaha, Hawaii, on the island of Kauai. At about 4:57 p.m. Hawaii Standard Time, a helicopter operated by Safari Aviation as a commercial air tour flight encountered instrument meteorological conditions and collided into terrain in a remote wooded area. The weather on Kauai had been favorable for tours for most of the day. However, just before the accident, flight departed, low clouds and rain began moving onshore from the northwest. This was an atypical weather pattern for Kauai and affected locations on the tour route, including areas where the accident flight was headed. At least 3 other tour pilots saw the adverse weather and decided to divert their tours away from it. The accident pilot, however, decided to continue his tour into deteriorating weather, eventually losing adequate visual references before the helicopter struck terrain. The pilot and all 6 passengers were fatally injured. On behalf of the entire National Transportation Safety Board, I want to extend our deepest condolences to those who lost loved ones in this terrible tragedy. We are truly sorry for your loss. Though we can't take your pain away, we can promise you this: the NTSB will not rest until the safety recommendations stemming from this tragedy are implemented. I often say that finalizing the report is just the first step. Real safety change comes when our recommendations are implemented, and in this case, we talk about several recommendations we've issued that could have prevented this accident, but those recommendations still have not been implemented, and as a result, more lives were lost. In a moment, the NTSB investigative team will walk us through the sequence of events surrounding this crash in detail. Each board member has studied the draft report and met individually with the investigative team. This is the first time we've gathered as a board to discuss the report. NTSB staff will present the pertinent facts and analysis and summarize their findings. After the presentations, board members will question staff on the key safety issues uncovered during the investigation. These include pilot decision-making, monitoring of Air Tour pilot operating practices by Safari and the Federal Aviation Administration, and helicopter safety technologies. Staff will then propose the relevant findings, probable cause, and safety recommendations for board consideration. Following the incorporation of any amendments voted on today, the final report will be available on our website in a few weeks. The public docket for this investigation was released on December 15, 2021, and contains over 1,500 pages of additional relevant material, and it's available on our website at ntsb.gov. Before we begin, I'd like to thank the following groups that served as parties to our investigation. While they're not part of the analysis, parties are crucial in helping us develop the facts around an investigation. The parties to this investigation were the Federal Aviation Administration and Safari Aviation Incorporated. In accordance with the provisions of Annex 13 to the Convention on International Civil Aviation, France's Bureau of Inquiry and Analysis for Civil Aviation Safety, or BEA, participated in the investigation as the accredited representative of the state of manufacture of the airframe and engine. Airbus helicopters and Safran engines participated as technical advisors to the BEA. I'd also like to thank our colleagues in the Office of Aviation Safety and throughout the NTSB for their hard work on this investigation and in putting together this draft report, proposed findings, proposed probable cause, and proposed safety recommendations. I'll now ask Deputy Managing Director for Investigations, Brian Curtis, to introduce members of the NTSB team participating in today's meeting. Good morning, Mr. Curtis.
Good morning, and thank you, Chair Homendy. A few announcements before we get started. I kindly request the folks here in the boardroom, if you have not already done so, please silence your mobile phones and other electronic devices. Should there be a need for any reason to evacuate the boardroom, there are 2 exits in front of the auditorium, one to my left and one ahead of me to the audience's right. Go down the stairs, out the door, and follow the illuminated exit signs to depart the building. You may also exit to the rear of the auditorium and proceed out the glass doors you entered, go up the stairs, and exit straight ahead through the large glass doors to the outside. Once you have exited, turn left and follow the sidewalk to the end of the street. In the event of an emergency, please walk quickly to the nearest exit and make your way to the outside following the instructions of NTSB staff. Do not return to the boardroom until instructed or advised to do so. If you have any questions or concerns, please don't hesitate to contact any NTSB staff. Thank you. I'll now introduce staff that will be participating in the discussions this morning. Unless otherwise noted, staff are from the Office of Aviation Safety. In the front row, left to right, Mr. Tim LeBaron, Director for the Office of Aviation Safety, Bryce Banning, Investigator in Charge, Dr. William Bramble, Human Performance, and Mitch Gallo, Operational Factors. In the second row behind me, from left to right, Casey Blaine, Deputy General Counsel for the NTSB, Kathy Gagne, Report Writer, Mike Richards, Meteorology, Van McKenney, Airworthiness, and Nathan Hoyt, Safety Recommendations from the Office of Safety Recommendations and Communications. And in the third row from left to right, Mark Ward, Visuals and Timer, Catherine Catania, Acting Director for the Office of Safety Recommendations and Communications, Jim Ritter, Director for the Office of Research and Engineering, and Dr. Taran Kayagil, Medical Officer from the Office of Research and Engineering. Presentations will begin with an accident overview by the investigator in charge, Bryce Banning. Mr. Banning.
Good morning, Chair Hamady, Vice Chair Landsberg, and members of the board. On December 26, 2019, about 4:57 p.m. Hawaii Standard Time, an Airbus AS350 B-2 helicopter operated as a Part 135 air tour flight by Safari Aviation collided into terrain near Kekaha, Hawaii. The helicopter was destroyed, the pilot and 6 passengers were fatally injured. The accident pilot, who was also Safari's chief pilot, arrived at the company's office in Lahui about 6:45 in the morning and printed the weather information for the day. He was scheduled to fly 8 50-minute nonstop tour flights. The standard tour route is shown in yellow on the map. The accident pilot's first tour departed at 8:25. He completed 4 tour flights in the morning, had about a 1-hour break for lunch, then completed 3 afternoon flights before departing Lahui at 4:31 on the accident flight. The weather was favorable most of the day, but adverse weather began moving in, affecting the northwest side of the island about the time the accident flight departed. A pilot for another tour operator flew a tour in Waimea Canyon between 4:22 and 4:29, about 21 minutes ahead of the accident helicopter. He said he saw a big front coming in, or at least clouds and rain from the west. He said Upper Mike, which was a reporting point location for tours exiting Waimea Canyon over the canyon's west rim, was obscured. Onboard video from this pilot's tour showed that about 4:27, his tour was in Waimea Canyon with an area of visible moisture ahead. Another Safari pilot who was flying a tour on the day of the accident that transited the Nepali coast about 4:30 said that a weather system was starting to move in and recalled telling his passengers they had just beaten the weather. Weather radar coverage on the north side of the island was limited below 5,000 feet, as shown in this figure, providing limited information about weather on the north side of the island. However, partial radar information was available for the northwest coast. These time steps of weather radar imagery depict Kauai being impacted by rain from the north-northwest in the afternoon on the day of the accident, as highlighted by the 3 arrows. The investigation confirmed that the deteriorating weather extended along the Nepali coast. Limited information was available about the accident helicopter's flight path. Air traffic control radar returns showed that a VFR aircraft departed Lahui at the time of the accident flight's departure and proceeded along the standard tour route before the return ceased. Presuming the accident pilot continued on the standard tour route in a clockwise loop around the island, he would have reached Upper Mike about 4:50. This figure shows the location of a typical tour route, the accident site, and the location of a witness who was hiking along the Nulolo Trail. The witness reported that heavy rain fell between 4 and 4:45. He was hiking along a ridgeline when he heard what sounded like a helicopter hovering nearby, but he could not see it. He noticed that the fog was very dense and the visibility was about 20 feet at his location. After hearing the helicopter for 30 to 50 seconds, it sounded to him as if the helicopter was turning or moving across the sky. He next heard a strange squealing noise, and then he could no longer hear the helicopter. The helicopter impacted the north face of a steeply sloping ridge that rose about 200 feet above the floor of an east-west oriented valley. The impact area, which consisted of disturbed terrain, extended from just below the ridgetop downslope to the main wreckage. A pilot for another helicopter tour operator estimated that his tour was about 5 minutes behind the accident flight when he heard the accident pilot transmit Upper Mike over the radio. Onboard video from this pilot's tour showed that his tour arrived at the north end of Waimea Canyon about 4:57 and encountered visible moisture in the canyon. The tour proceeded north of the canyon for about 2 minutes, but found that the weather ahead on the intended route wasn't as good as he thought it would be. He ultimately reversed course and diverted his tour to avoid the weather. After a comprehensive review of the circumstances that led to this accident, staff concluded that the accident pilot continued flight into an area of deteriorating weather. However, due to the limited information about the helicopter's flight track and the lack of recorders on board, it could not be determined whether the pilot maintained control of the helicopter after encountering instrument meteorological conditions or lost control of it before impact with terrain. The investigation found no evidence of safety issue deficiencies in the following areas: pilot qualifications, pilot medical conditions, and helicopter mechanical malfunction or failure. The safety issues identified in this accident include a lack of communication and ADSB infrastructure along air tour routes in Hawaii, a lack of real-time decision-making support for air tour pilots, a lack of FAA guidance for operators on the implementation of queue-based training, the lack of an ADSB out requirement for Hawaii air tour operators, a need for improved FAA surveillance of air tour operations in Hawaii, the importance of the adoption of helicopter safety technologies for helping pilots escape inadvertent encounters with IMC, the lack of an FAA requirement for safety management systems for smaller operators, as well as guidance on SMS scalability, the need for flight data monitoring programs for Part 135 operators, and reviews of onboard video and ADSB data as part of a safety insurance program. The lack of a requirement for crash-resistant flight recorder systems for all existing turbine-powered, non-experimental, non-restricted category aircraft, and delays in the FAA's implementation of an aviation weather camera program in the state of Hawaii. Staff has proposed recommendations and reiterations in these areas. I would like to acknowledge the following staff who supported the investigation. Parties to the investigation were the Federal Aviation Administration and Safari Aviation. In accordance with ICAO Annex 13, an accredited representative was appointed by the Bureau of Inquiry and Analysis for Civil Aviation Safety, or BEA, as the state of manufacturer with Airbus helicopters and Safran helicopter engines named as technical advisors. Thank you. Dr. Bill Bramble will continue.
Good morning. I will be discussing pilot decision-making, safety assurance, safety management systems, and emerging technologies for preventing accidents involving inadvertent encounters with IMC. As Mr. Banning stated, this accident occurred when the pilot continued VFR into an area of deteriorating weather conditions until he lost adequate visual references. Staff determined that his decision-making was likely influenced by an atypical weather pattern and a lack of relevant weather information. Northeast trade winds normally bring clouds and rain to the northeast side of Kauai. On the afternoon of the accident, however, northwest winds brought clouds and rain to the northwest side. This was an atypical weather pattern. The orange circle on this slide denotes the area of high terrain north of Waimea Canyon where the accident occurred. Pilots cannot see this area when flying inside the canyon. Good weather was present there during the pilot's previous flight, but the weather subsequently deteriorated. When the pilot reached the north end of Waimea Canyon during the accident flight, low clouds, rain, and reduced visibility were present. This video still image shows North Waimea Canyon about 23 minutes before the accident flight arrived. The northwest rim of the canyon is visible but appears partially obscured. The pilot, who was flying the helicopter from which this picture was taken, and the pilot of another helicopter shown in the orange circle, decided to divert northeast rather than climb over the canyon rim. This image shows a closer view of the northwest rim about 7 minutes after the accident flight transited the area. Low clouds and rain were still present. The pilot who was flying this helicopter continued over the canyon rim before reversing course and diverting. The accident flight likely encountered a level of deterioration between what was shown in the last photo and what is shown in this photo in the north end of Waimea Canyon. When the pilot of the accident flight decided to climb over the northwest rim of the canyon and continue north, he likely expected a brief weather encounter. Instead, he entered a widespread area of poor weather that extended all the way to the coast. Pilots need relevant information to form accurate expectations. 2 weather reporting sites existed on Kauai, one at Lihue Airport and the other at Barking Sands Airport. However, no reporting sites were located on the north side of the island. A weather radar on the south side of the island was partially blocked by high terrain. Therefore, pilots in Hui had limited information about how conditions were changing on the north side of the island. A lack of relevant information increases the difficulty of making appropriate weather-related decisions before each flight. The NTSB has previously urged the FAA to initiate an aviation weather camera program for Hawaii that would allow pilots to view conditions in remote areas. By 2019, the FAA planned to install 23 weather camera facilities across the state, including 5 on Kauai, but none were installed before this accident. A camera on the northwest side of the island could have allowed the pilot to see deteriorating weather there before departing Hui. In 2021, the FAA installed 2 camera facilities on Kauai in the locations shown on this slide. However, neither provides images of the northwest side of the island where the accident occurred. Staff proposes reiterating recommendation A1325 to encourage full implementation of the Hawaii Aviation Weather Camera Program. Staff also considered 2 additional factors that can influence pilot weather-related decision-making: inadequate in-flight weather assessment and inaccurate risk perception. There was insufficient evidence to determine the likelihood that these factors influenced the pilot's decision to continue flight into deteriorating conditions. However, it's possible these factors played a role. Research indicates that pilots sometimes continue visual flight into adverse weather because they do not adequately recognize when conditions have deteriorated to the point that they're becoming unsafe. However, pilots can be trained to make better in-flight assessments by viewing photorealistic depictions of weather, receiving feedback on the accuracy of their estimates, and being familiarized with environmental cues that should prompt a diversion. This approach is known as cue-based training. In 2007, the NTSB urged the FAA to develop and require cue-based training for Hawaii Air Tour pilots. In 2008, the FAA informed the NTSB it was requiring cue-based training. In 2011, the FAA said it had assembled an interdisciplinary team to develop related guidance, but none was issued. As a result, Safari did not provide the pilot the kind of training FAA research has determined can improve pilots' in-flight weather assessments. The FAA's efforts to aid the development, production, and maintenance of cue-based weather training programs have been inconsistent. Therefore, staff proposes reiterating recommendations A7, 18, and 19, which ask the FAA to work with Hawaii Air Tour operators, aviation psychologists, and meteorologists to develop a cue-based weather training program for Hawaii Air Tour pilots and require Hawaii Air Tour operators to provide it. Risk perception can play a role in errors at the action selection stage of decision-making. Like drivers on the highway, pilots may have higher than average self-appraisals of skill and judgment in flying, and this can have implications for perceptions of risk and willingness to engage in high-risk behaviors. The pilot was described by most as safety conscious, but a pilot colleague at another company said that due to the pilot's expertise, he sometimes flew closer to adverse weather than more novice or conservative pilots. Maintaining the required minimum 3-mile visibility would have provided the pilot the opportunity to avoid hazardous conditions during the accident flight. The pilot's decision to proceed north of Waimea Canyon when others diverted, and his continuation of flight into deteriorating conditions until a crash occurred, suggests the possibility that he was overconfident in his ability to fly safely through an area of poor visibility. Safety theorists assert that work performed by system operators, such as pilots, often differs from the work as described in policies and procedures, and that work practices can, under some circumstances, deviate beyond safe boundaries. Although 3 other pilots diverted before reaching the accident area, Video evidence indicates that all flew in low visibility conditions that may have been below required minimums. This raises the possibility of a drift toward risky operating practices among members of the local air tour pilot community. Operational monitoring is needed to detect and correct possible drift toward risky operating practices. And this could be accomplished as part of a safety management system, or SMS. SMS is a formal top-down, organization-wide approach to managing safety-related risks. Components of SMS include safety policy, safety risk assessment, safety assurance, and safety promotion. Operational monitoring is part of safety assurance. Although Safari had a policy that defined company expectations for pilot adherence to minimum weather requirements, it did not have adequate safety assurance processes to determine whether these policies were effective. To increase operational monitoring, staff proposes reiterating a recommendation to the FAA to require Part 135 operators to install flight data recording devices and establish flight data monitoring programs. Staff also proposes a new recommendation urging the FAA to encourage air tour operators to establish safety assurance processes to routinely review recorded onboard videos and ADS-B flight tracking data, ideally as part of an SMS. The NTSB has long encouraged the FAA to require the implementation of SMS, but it is not required for Part 135 operators like Safari. Safety assurance activities are most likely to be effective in the context of an integrated SMS. Therefore, staff proposes reiterating recommendation A1636 that urges the FAA to require SMS for Part 135. Safari's president believed Safari was too small to maintain an SMS, and Safari did not implement one. By design, SMS is scalable to allow the integration of safety management practices by an operator, and staff believes the safety of air tour operations, regardless of size, would be enhanced by the implementation of SMS. However, guidance on the scalability of SMS for small operators is lacking. Therefore, staff proposes a recommendation that the FAA develop and distribute guidance on the scalability of SMS. Inadvertent flight into IMC is a leading category of fatal helicopter accidents. Efforts to reduce such accidents have historically relied on pilot avoidance of low visibility conditions, but such accidents have persisted. A recent white paper published by the U.S. Helicopter Safety Team argued that if all rotorcraft met some IFR stability requirements, which can be provided through such features as force gradient trim and stability augmentation, pilots would be better able to maintain control and maneuver in ways that increase terrain clearance during a temporary loss of outside visual cueing. Historically, complexity, weight, and cost have made automatic flight control technologies impractical for normal category helicopters. But existing technologies have matured and new solutions are being introduced. Staff proposes a recommendation to the FAA asking for the issuance of a special airworthiness information bulletin that lists newly manufactured helicopters, equipped with features likely to reduce accidents involving inadvertent flight into IMC, describes retrofit options for helicopters that do not have such equipment, and encourages voluntary integration of these safety features. Voluntary adoption of these technologies could also be achieved by reaching out directly to tour operators. Tour Operators Program of Safety is an independent nonprofit organization dedicated to enhancing the safety of helicopter air tours with members in 7 states, including Hawaii. TOPS could help promote voluntary adoption of safety technologies among air tour operators. Staff proposes a recommendation to TOPS asking TOPS to inform its members and the broader air tour community about the circumstances of this accident, provide information about helicopter technologies for reducing the risk of accidents involving inadvertent encounters with IMC, and encourages air tour operators to voluntarily incorporate such technology. An additional opportunity for encouraging the adoption of technological countermeasures. is by leveraging a new safety rating program. An international industry government organization, the Vertical Aviation Safety Team, or VAST, plans to introduce a safety rating for helicopters to increase awareness of and incentivize customer demand for safety-related design enhancements. A VAST working group has begun working on criteria for the proposed rating system, but it has not yet established whether this rating system will include the incorporation of technologies for reducing weather-related accidents. Staff proposes a recommendation to VAST to include in its rating system a consideration of these technologies. Training aimed at reducing VFR into IMC accidents could be enhanced by the use of simulation technologies. In 2020, the U.S. Helicopter Safety Team encouraged greater use of helicopter simulation at all levels of fidelity, including aviation training devices, flight training devices, and full flight simulators. Emerging technologies such as head-mounted augmented reality displays could also simulate changing weather and allow pilots to practice IMC avoidance and escape maneuvers while experiencing actual flight forces. The NTSB has previously recommended that the FAA require the use of appropriate simulation devices during initial and recurrent pilot training on hazardous weather avoidance and escape for Part 135 helicopter operations and evaluate spatial disorientation simulation technologies to determine which would be beneficial to pilot training. Existing and emerging simulation technologies could be used to improve the training of helicopter pilots in the avoidance and escape of hazardous weather conditions and might aid the recognition and mitigation of spatial disorientation. Therefore, staff proposes reiterating recommendations A21, 5, and 6 to the FAA. This concludes my presentation. Mr. Gallo will continue.
Good morning. I will discuss operational factors in this accident. Staff's investigation revealed the need for real-time decision-making for air tour pilots, aviation infrastructure improvements, improved FAA surveillance, and crash-resistant flight recorders. Kauai has dynamic weather conditions. After departure, pilots rely on in-flight visual assessments and radio reports from other pilots for updated weather information. As Dr. Bramble indicated, limited weather information may result in a continued flight into deteriorating weather. Weather cameras will provide more timely weather information, and when this occurs, pilots would benefit from real-time ground-based decision support. To provide this kind of support, operators must be able to reliably communicate with and track their flights. However, existing aviation infrastructure on Kauai is not adequate to support this. Terrain precludes radio communications between operators in Lihue and their low-flying aircraft on the north side of Kauai. As a result, ground personnel cannot communicate with or offer guidance to other pilots throughout much of their tours. Technology is available for extending radio coverage to low-flying aircraft on Kauai. Some, but not all, tour helicopters on Kauai are equipped with ADSB data link capability that allows ground personnel to track their speed, altitude, and location. At the time of the accident, Safari did not have this equipment installed on their helicopters, but they installed it after the accident. However, terrain in the center of Kauai blocks the transmission of ADSB information between low-flying aircraft and ADSB ground stations near Lihue. This precludes operators from continuously tracking tour flights on the north side of Kauai using ADSB. The NTSB has long advocated improvements to ADSB infrastructure in Hawaii. In 2007, when the FAA was beginning to install the technology around the country, we recommended that the FAA accelerate the implementation of ADSB infrastructure in Hawaii, design it to support low-flying aircraft, and require Hawaii tour operators to equip their aircraft with ADSB. In 2014, the FAA told us that tour operators had declined to install ADSB and that investments in expanding the ground infrastructure would not yield safety improvements unless the tour operators had the appropriate avionics. The FAA completed its installation of ADS-B ground infrastructure in 2015, which did not extend to low-flying aircraft, leaving gaps on the north side of Kauai. The ADS-B infrastructure in Hawaii is insufficient to adequately enable ADS-B out and in supported services, such as real-time flight position tracking, which is essential for the safety of low-flying air tour aircraft throughout the entire air tour route on Kauai, and useful in supporting safety assurance. We propose to the FAA to implement ADS-B infrastructure improvements in Hawaii to enable low-flying tour aircraft equipped with ADS-B to transmit data and receive services throughout their entire air tour. Also, we propose that the FAA require Hawaii air tour operators to equip tour aircraft with ADS-B to enable real-time flight position tracking. It is not uncommon in Part 135 operations for tactical decisions to be performed exclusively by the pilot with little or no input from those persons that exercise operational control. The shortcomings of this approach include pilot vulnerabilities to the limitations of in-flight visual assessments and overconfidence, as previously discussed. Safari had front desk personnel who performed flight locating duties. However, like most Part 135 operators, the company was not required to have trained flight support personnel with operational control authority to provide flight-related decision-making support to pilots. Evidence from the air ambulance and law enforcement sectors indicates that such support can help reduce accidents. Operational control functions can be scaled and adapted for use by tour operators, which can also be beneficial in operating areas of rapidly changing weather. Operations control personnel could participate in pre-flight risk analysis, provide pilots with updated weather, monitor the progress of flights, communicate with en route pilots, and provide advice on diverting a flight, supporting operations safety assurance activities. We propose a recommendation to the FAA to require tour operators to have flight support personnel who are trained to exercise operational control authority, participate in pre-flight risk analysis, provide pilots with weather briefings, monitor the progress of the flights, and participate in two-way communications with pilots to alert them of any weather hazards. The Honolulu Flight Standards District Office, or FSDO, had a large geographic territory which created logistical challenges for FAA inspectors to visit operators for surveillance. Interviews with FSDO personnel revealed that from 2013 to 2016, surveillance of air tours was accomplished through industry outreach meetings and in-person surveillance, some of it covert. By 2017, the FSDO was experiencing a shortage of operations inspectors, with only 2 of 6 positions filled by fully trained personnel. And the FSDO's ability to perform routine in-person surveillance of tour operations decreased. As a result, the FSDO struggled with surveillance, and the responsibility for surveilling some operators was transferred to another FAA office on the mainland. The FSDO manager told investigators that updating the 2008 Hawaii Air Tour Common Procedures Manual, or HAT CPM, which imposes safety-related requirements on air tour operators, was the focus of her air tour surveillance activities during this time. However, progress on the revision stalled. A revision has not been issued, and the FAA has been unable to provide the NTSB an estimate date of revision or replacement. The Honolulu FSDO's risk-based surveillance prioritize the use of limited inspector resources. Operators that score low on known risk factors receive less surveillance. Staff believes there is value in performing routine surveillance of the flight operations of Hawaii Air Tour companies, even those that have not had a recent accident or are not otherwise deemed high risk. Safari was not identified as a high-risk operator, yet they experienced this accident. Due to day-to-day economic and efficiency incentives, there may be a tendency among tour pilots to take on increased weather-related risks until they encounter a situation they cannot escape. FAA surveillance could help stop this kind of drift toward risky operating practices. However, traditional surveillance methods are resource-intensive, and the FAA has struggled with maintaining the necessary staffing. Technology could permit innovative strategies for conducting operational oversight. These strategies could include a trend analysis of archived NTSB data, in conjunction with archived weather camera images, or periodic reviews of tour operators' onboard video recordings. Increased oversight by the Honolulu FSDO using a combination of traditional and innovative approaches could decrease the likelihood of drift toward risky operating practices by tour operators and their pilots. We propose a recommendation to the FAA to improve the surveillance of air tour operations in Hawaii through the use of technologies and innovative approaches to detect and correct operating practices that may lead to unacceptable weather-related risky behavior. Certain circumstances of this accident and whether the accident resulted from controlled flight into terrain or an in-flight loss of control could not be determined. A crash-resistant flight recorder system could have provided this information and possibly enabling the identification of additional safety issues. Strategies for reducing controlled flight into terrain accidents involve enhancing pilot awareness of surrounding terrain. Strategies for reducing in-flight loss of control accidents involve enhancing the pilot's ability to maintain primary control. If all tour aircraft were required to be equipped with data, audio, and video recording devices, improved information about accident circumstances would permit more definitive accident analyses that could support additional recommendations for safety improvement. We propose the reiteration of recommendation A1313 for crash-resistant flight recorder systems. This concludes the staff's presentation.
Thank you, Mr. Banning, Dr. Bramble, and Mr. Gallo for that excellent presentation. We'll now turn to board member questions focused on three major safety issues the NTSB identified in this investigation. First, pilot decision-making. Second, company and FAA monitoring of air tour pilot operating practices. And third, helicopter safety technologies. Before we consider the draft findings, we'll also entertain a final round of questions on any other safety issue that board members would like to raise. The purpose of this discussion and focused deliberation is to highlight those areas where we believe we can make the biggest difference to improve safety. Some members may have questions in these rounds, some may not. So we'll begin the discussion on the first issue, pilot decision-making, with Vice Chairman Landsberg.
Thank you, Chair Homendy. This pilot had nearly 16,000 hours of flight experience and almost 6,000 hours in the make and model of aircraft. He was the chief pilot of the flight operation, had given instructions, and yet we're having this kind of discussion here. You know, the other three other pilots or four other pilots from other tour companies decided to bail out. How do we get into this situation? And I realize maybe it's somewhat rhetorical, but for VFR operations, what part of cloud and rain doesn't a pilot understand? I guess maybe Dr. Bramble, I'm looking at you.
Well, we think this was kind of a two-part decision. when the pilot got to the north end of the canyon, he saw deteriorating weather and he had to make a decision. And we think he mentally simulated what would happen if he climbed over that rim, and we attributed his decision to do that and maybe take that chance to an inaccurate mental model of what the weather was on the other side due to the atypical weather pattern and the lack of information about the conditions. In addition, there's this possible issue of deficiencies in the assessment of the visibility and cloud ceiling in real time, and the potential for incremental steps toward risky operating practices under economic and workload pressures.
I heard you mention economic factors. I think we can agree on that. What's been the FAA's response on installing weather cameras? How many cameras would it take to cover the north side?
I'm not sure exactly how many cameras would be required. However, the FAA is proposing to install 6 total cameras on Kauai, actually 5 of those along the north side of the island, and we're pleased that they're doing this.
Do we have any kind of time estimate?
For installation on Kauai, they expect Q1 of fiscal year 23.
Okay, that's good. Videos from the other flights showed that the weather was clearly deteriorating, and just based on my observation, they were getting way too deep in. I believe their minimum flight visibility was 3 miles, is that correct? So just based on my experience of flying in and around weather, it didn't look to me like they had anywhere near 3 miles, and it was clearly getting worse. So despite the regulations, there's sort of a routine non-compliance here. We saw that from multiple different organizations. Any sense of why pilots we know that the rules say 3 miles, and yet the helicopters being surrounded by fog and clouds and rain, and the pilots are pushing, and then finally they say, whoops, we're in over our heads. Any thoughts on that, or is that sort of a iteration of what you previously said, Dr. Bramble?
Well, it's related to some of those concepts, but we don't think that they wake up one day and just begin flying through areas where they can't see very well. We think it's sort of an incremental uncoupling between the procedures and requirements and what the actual behavior is on the flight routes. Sort of a drift where they maybe decide to push it a little further, and then that becomes sort of the new normal, and that sets the basis for additional deviations that are sort of normalized by the community because everyone sort of is willing to take that step.
So we follow the herd mentality. In 2007, we recommended Q-based weather training, and the FAA failed to respond. Did they provide any reasons as to why they did that?
No, not initially. They did eventually form a group, and they made some attempts to implement that in Alaska, but they never did follow through in Hawaii.
You stated in the report that the Q-based weather training programs were inconsistent. I think I would restate that as non-existent. So, Chair, thank you very much.
Thank you. Member Graham.
Thank you, Chair Hominy. Per its FAA-approved operations spec, Safari was authorized to deviate from the minimum altitude specified in Part. Okay, I don't know how much you heard there. I hear myself now. Per its FAA-approved op spec, Safari was authorized to deviate from minimum altitude spec in Part 136, Appendix A, and conduct air tour flights below 1,500 feet AGL on the islands of Kauai and Hawaii. This authorization was issued by the Honolulu FSDO. Were there other requirements that they were required to follow?
The deviation authority was based on the Hawaii Air Tour Common Procedures Manual, and that's correct.
Okay, so they had another manual that had other further requirements in here and limitations, is that correct?
That's correct.
Okay, one of them being that the vice chair had already talked about was the minimum visibility of 3 nautical miles.
That's correct. They had CPM raise of visibility to 3 miles.
What's a normal Part 135 minimum visibility?
That's half mile
Half
visibility.
mile, so more restrictive. How about the altitudes, especially north of Waimea Canyon? What was the altitude supposed to be at? Or what was their minimum altitude they could be at?
The tour routes could range from altitudes from 500 to 1,500, depending on the area. The accident site was in an area where minimum altitude would have been 1,500 feet.
Okay. Do we believe we had that kind of clearance with the weather at the time of the accident?
We don't know what the pilot was seeing at the time of the accident. That's why we're proposing one of our recommendations for onboard recorders.
Okay. Do we think he met the minimum requirement for visibility?
No, we believe the evidence suggests that the weather had deteriorated and the pilot encountered instrument meteorological conditions.
Exactly, I agree with you there. So within that manual, it also says here, if an in-flight deviation required immediate action or deviation from any of the requirements set forth in this manual, the PAC may deviate to the extent necessary to meet the circumstance. Okay, that's under the in-flight deviation authority requirements. It also says here, each person who deviates from the regulations and/or requirements set forth in this manual shall contact the POI or FSDO manager within 10 days of such deviation, if so requested, and if so requested, file a written report. Would you say, looking at the weather pictures that were provided us by some of the other operators at the time and some of the video that is in the docket that I know most of us have seen and watched, would you say that that kind of the weather, I believe we agree, was below 3 miles, would that require a deviation to contact the FSDO or the POI?
Yeah, the weather below 3 miles is a deviation from the HAT CPM, so you would have to make a report if requested in writing.
Okay, and looking at some of those pictures that I've seen in the docket of near that time of the accident, are we aware of any of those other operators having filed a deviation report with the FSDO?
We received no reports from the Federal Aviation Administration on a report.
No reports. I'm not surprised, and I think this shows a obvious sign of procedural drift that has occurred in the Kauai Air Tour operations area, which is very unfortunate. And with that, I'll yield back the rest of my time.
Thank you, Member Graham. Member Chapman.
Thank you, Chair. I think my mic is on, yes. On the day of the accident, first of all, thank you all very much for your good work on this investigation. And thank you for working with me on some of the concerns that I had with respect to the earlier draft. I think it's an excellent product, and I congratulate you. On the day of the accident, the pilot had already completed multiple tours, and I believe the accident flight was his 8th of the day. Before taking off for his final tour, what sources of weather information were available to him? And I guess just as important, would he have had sufficient time before takeoff to complete a thorough check of the weather conditions?
So time is clearly tight between these tours. It's typically on the order of 10 minutes, and often they're refueling the helicopters, so there isn't a lot of time. And they have to provide a briefing to passengers as well, which is one of the reasons why we're suggesting maybe more operational support for pilots while they're in flight. As far as what weather information was available, I'd have to defer to Mr. Richards.
Well, we know when he checked the weather that morning, he looked at the TAF for Lahui, which was the airport he was departing in and out of, and also area forecast, which is text weather that really covers a broad area of the islands of Hawaii.
But that check was done early in the day. And at this point, we're late afternoon. So there really hasn't been a thorough assessment of the weather since before he went on duty, as I understand it. In addition, it's my understanding the pilot would have had to rely on, to the extent, frankly, he had the time to check, he would have had to rely on weather reports and forecasting, I believe from Barking Sands Airport, which is about 8 miles from the accident site, and weather radar data from South Kauai, which is about 16 miles from the accident site. Am I correct about that? And would either site have been capable of providing adequate weather information to alert the pilot to the unusual conditions he would ultimately encounter?
That's correct. So Barking Sands was the closest station that had a salometer and a visibility sensor, give you an understanding of ceiling and visibility, which was quite a few miles away. And you're correct, the weather radar was south and wasn't able to depict precipitation at very well below altitudes, 5,000 feet. So using these sources, the pilot would not really have been able to get a good sense of the weather that was occurring at the accident site, I believe.
Thank you. What is the flight altitude for a typical air tour in the Waimea Canyon area? And is it, and I assume it is, below the line of sight coverage for the nearest weather radar located at South Kauai?
The minimum altitude for that Waimea area is 500 feet, and you're correct in the lack of radar coverage.
Before this accident, I understand there were no FAA cameras in the area, FAA weather cameras. Now I believe you indicated there are 2, and certainly the benefits of those cameras seem apparent. Did I understand you correctly that there are 6 planned, and that first quarter 2023 is the target date for installation of those cameras? 6 total?
On Kauai, yes, sir. That's the most recent information from the FAA.
A question with respect to Q-based. Actually, I'm gonna hold that question for the next round. Thank you, Chair.
Thank you, Member Chapman. A couple of questions. We'll start with Mr. Banning. Had the pilot stuck to the minimums of 3-mile visibility and 1,500 AGL, would the accident have occurred?
No.
And I believe it was Dr. Bramble had said efforts to reduce accidents involving VFR into IMC have historically relied on pilot avoidance of low visibility conditions, but such accidents continue. Do you think it's fair that we should continue to see accidents and just rely on pilots' decision-making? This is your opportunity to talk about our other recommendations.
So we have proposed a package of recommendations and reiterations that aim to support pilots in their decision-making, both by giving them real-time decision-making support, monitoring what they're doing to prevent them from drifting into risky operating practices, and also providing some technological solutions to make those situations of inadvertent encounters with weather more survivable when they do occur.
And some of these recommendations date back decades. Mr. Hoyt, how many recommendations do we reiterate in this report?
Sorry, we are reiterating the 2007 recommendations, so a total of, sorry, hold on 1 second.
It's 11.
11.
11 recommendations that we've issued for decades. So I'll come back to that. On the camera program, the weather cameras, You have experience in Alaska. You live in Alaska, Mr. Banning. Can you talk about how, the camera program in Alaska, what that's provided, the information it provides to pilot, how successful it's been, and how effective it's been for Alaska pilots?
Yeah, I think the weather camera system program in Alaska has been very successful. They have a still day or a clear day image compared to the conditions at the time. They typically have landmarks in the clear day image so that a pilot can look at the image and see, get an idea of visibility, if he can see certain landmarks. And I would describe it as a very successful and program that benefits pilots. And then I believe Mr. Richards can provide some information about the other benefits to the program.
Well, I can share that in 2012, the FAA issued what they call the post-implementation report on the weather camera system in Hawaii. And they indicated that the program coincided with and contributed to a 53% decrease in weather-related accidents in Alaska.
Great. And when did we first recommend that FAA install and maintain aviation weather cameras in Hawaii?
We made a recommendation in 1995 out of a study on improving safety in Alaska, and the FAA looked at, it's worked with the National Weather Service to see if that was technically feasible, and then that was sort of the basis or the foundation for our recommendation in 2008 for installing weather camera.
Great. I'm sorry, did you say and then our recommendation for Hawaii was when?
2013.
2013.
But
Great.
in 08 was the recommendation
And what's taken
for
so
Alaska.
long?
The FAA, there was a delay in the FAA's response to the 2013 recommendations for about 3 years after we issued it. The FAA initially planned to use existing cameras to respond to the recommendation, and we said that wasn't acceptable because it would not allow the FAA to capture images in remote locations.
Yeah, I think it's very interesting that several of the tour pilots had stated in interviews that they used 3 privately operated cameras to supplement approved sources of weather information for Kauai. So that's unfortunate that they had to seek out other information when the FAA could have acted sooner. Vice Chairman Landsberg.
Thank you, Chair. It sort of has the feeling of deja vu all over again. How many accidents have we had in Hawaii over the last, say, 20 years or so of air tour?
We've had about, between 2000 and the end of 2019, we've had 11 fatal accidents involving helicopters and helicopter air tours, and 6 of those were weather-related.
That's pretty remarkable, considering. One thing that kind of stuck out at me in looking at the videos is there appeared to be a lack of forced landing sites as you get into the Waimea Canyon, and of course that's where the weather seems to be. And that's typically one of the escape mechanisms that helicopter pilots have always had. We saw that in Calabasas, that there were plenty of opportunities to find a place to land. But that doesn't seem to be the case in some of the tour areas. Would you care to comment on that in terms of how one is supposed to deal with a forced landing situation, either due to a mechanical situation or due to weather?
Well, in this case, altitude would be your friend, and you'd have to survey for possible landing sites as you proceeded along the route. So the lower you get, the more restricted you are in the areas you could land.
Well, that doesn't quite answer the question, though, in that it doesn't look like even at 1,000 feet, you'd have a lot of flat places without vegetation to land in. Is that a fair statement? And I read in the HAT CPM that they said, you know, you need to have certain places that you can go. And it looks to me like we're sort of whistling past the graveyard on this in terms of what would be a minimum safe altitude. And obviously, within the area over Waimea Canyon, because of the weather and so forth, we have made a very calculated decision to say we'll allow you to go as low as 500 feet AGL. Any comment on that? Is that a realistic altitude, or is it just kind of being hopeful?
Well, I think the HAT CPM intended to help address some of those issues that you brought up for tour flights.
The revised HAT CPM, is that correct?
I don't think there is a revised HAT CPM.
No, I understand that, okay. Mr. Manning, any indication from the previous flights coming in and within radio contact of Lihue, any information there that the weather was deteriorating over on the north side of the island that maybe the accident pilot would have picked up upon?
The radio communications that pilots would have been talking on amongst themselves was not recorded, and we don't have any indication that information about the weather was shared among the pilots, and there were no PIREPs that were filed.
Okay, and we also do have a recommendation to the FAA dating back, I believe, to 2017 regarding pilot reports and the importance that is critical. Is that right, Mr. Richards?
This is several years ago, we issued a large report. Actually, it's going back a few more than several years, but we've spent quite a bit of time as staff and with the board of this agency addressing the lack of PIREP information and how critical it is for safety.
So had there been pilot reports here, if there'd been an ability to get the radio out from low altitude, which would mean another tower, not tremendously expensive or difficult, pilots could have called in and said, hey, it's really getting bad here out on the north end of the canyon, recommend that you divert. One last question. The weather, it was noted, was moving in from the northwest instead of the northeast. Okay, that's somewhat unusual, but why is that such a big deal?
So when you have a northwest wind, you get upslope flow on the island, on that side of the island. Upslope flow can enhance low clouds and rain. Normally, we would see that on the northeast side. And so it's relatively uncommon to see it on the northwest side of Kauai.
So the point being, though, that if the weather's coming from a different direction than what you normally expect, don't go there. So anyway, thank you, Chair.
Thank you, Vice Chairman. Member Graham.
Thank you, Chair Hamady. Did this helicopter pilot have an instrument rating?
No, he did not.
He did not have an instrument rating. Do you know how many of these accidents we see a year? A helicopter continued flight into inadvertent or into instrument meteorological conditions and then associated with either loss of control or controlled flight into terrain? You know how many of these we're doing a year here at the NTSB?
We don't have those statistics nationwide available, but I know for air tour in Hawaii, we're averaging about 2 to 3 per decade.
Okay, yeah, but overall in the U.S., I know, I did this last year when we did the Calabasas. We do 2 to 3 of these a year we're seeing here at the NTSB. What has the FAA or the helicopter community done in recent years to prevent these types of accidents, which is BFR into IMC?
Well, the U.S. Helicopter Safety Team has attempted to take a data-driven approach to improving safety by analyzing a sample of over 180 accidents that occurred during the 2000s and 2010s. And they've released a number of proposed safety enhancements that include everything from training strategies to equipment improvements and so forth.
Has it been very effective to this point, in your opinion?
I would say we're at early stages with actually seeing some implementation and benefit from those strategies.
Yeah, we just don't know yet, do we? And it's unfortunate, this pilot's not instrument rated, so if you go into the weather, what's the first thing you need to do is get on your instruments, but if you're not instrument rated, if you're not instrument current, and you're not instrument proficient, it does you no good, does it? No, and here we are again. We have a VFR-only helicopter, a VFR-only pilot who's flirting with marginal weather. And sooner or later, if you continue to flirt with low ceilings and reduced visibility, a percentage of them are eventually going to go into the weather. And unfortunately, a percentage of them, we see a high percentage of them will not survive in the end. Chair, I yield back the rest of my time.
Great. Member Chapman.
Thank you, Chair. I want to pick up briefly on the theme of Member Graham's questioning. I have no significant background at all in helicopter operations, but I recall one of the lessons that I took from the Calabasas investigation had to do with instrument operations in a helicopter. And as I recall, and I would ask you to elaborate or correct me if I'm wrong, even if this pilot had been instrument rated, even if the helicopter had been instrument equipped, it's my understanding that single pilot IFR operations in a helicopter is extremely difficult. So that compounds the problem even further in terms of stepping too close to the edge here. Am I correct?
Yes, inadvertent encounters with IMC, particularly in a normal category non-IFR certificated helicopter, is an emergency.
Thank you. Thank you. I have a question about cue-based weather training. And actually, this was a new concept to me. I'd not previously encountered this. What would a cue-based weather training module look like, which is specific to the island weather conditions typically encountered by tour operators in Hawaii?
So the original FAA research on this was pretty interesting. They looked at pilots, or they interviewed pilots and asked them to identify a situation where they may have gotten themselves into a weather-related situation that was not good. And then they asked them retroactively to identify which cues in the environment they could have paid attention to avoid that situation. They used that information to develop a training program to better get pilots to draw their attention to those cues in the environment. And then they showed them photorealistic views of weather, and they had them estimate what the visibilities and ceilings were, and they gave them feedback on the accuracy of their assessments. And then they put them into a simulation where they were asked to divert if needed, as the weather deteriorated. And they found a great improvement in the early decision to divert before conditions reached that point where an optimal divert decision was needed.
Thank you. So this is the sort of thing, it actually sounds like it could actually build on itself over time as the training is administered. You could learn lessons even from just conducting the training that could then be fed back in to enhance it further. Interesting concept, and I hope we'll see more of that in situations like Hawaii and Alaska, other parts of the country where I know these tours are popular and there's certainly risk in terms of weather conditions. Why does FAA seem to have been hesitant to make progress with the cue-based training?
We're not exactly sure what has led to the lack of implementation in Hawaii. They did require it, but they never developed the guidance. And what they really need to do is bring together a team with the right kind of expertise to create some courseware and some model curricula that are appropriate to that region.
Because it seems as though they required it, but they required it of folks that really had no basis for understanding completely what it was they were being required to do.
Yes, they really need to involve some decision-making experts that understand pilot psychology, and also some meteorologists and some local operators that know the terrain and the weather patterns in that area.
And are I believe there was an indication, I can't recall whether it was in the presentation or in the draft, that there is a Q-based weather training program being used in Alaska. Is that right?
There was. We actually had a chance to take a look at that in the Promec aviation accident investigation in the mid-2010s. And it was a PC-based simulation in that area where they would fly a mock tour flight, and then the weather would deteriorate and they were expected to turn around. It didn't have all of the components of a Q-based weather training as described in that original research, but it did provide at least some scenario-based training. However, that training is no longer being offered because the organization that was sort of hosting the equipment and so forth no longer exists in Alaska.
But there is at least a little bit of a template, while not perfect, at least a little bit of a template that could be imported here, obviously have to be tailored for the conditions in Hawaii, but we're not starting from scratch.
That's correct.
Thank you. I yield back my time.
Thank you, Member Chapman. And just to tag on to that discussion, I do want to back up because we keep referencing the HAT CPM, and I think some watching might not understand what that is. It's the Hawaii Air Tour Common Procedures Manual. Maybe you can talk about what that is and how that relates to Safari's FAA-approved operation specifications and deviations of minimum altitude.
So the Hawaii Common Air Tour Procedures Manual, which was originally issued in 2008, specified at certain site-specific locations, altitudes to enter those locations, exit, standard radio transmissions, and it also, of course, provided the initial and recurrent training of that manual, the minimum visibilities, minimum altitudes that you could fly at depending on the area that you're at in Kauai, and that was integrated into the company's operations specifications.
Great. And that manual included a requirement for Q-based training.
That's correct.
But what it did not do was provide, as Member Chapman said, what that training should include and how it should be delivered.
That's correct.
Which is what we wanted with our recommendation. We wanted guidance.
That's correct.
And so Safari, did they believe they had Q-based training? And do you believe they did?
So we asked them what they were doing to abide by the requirement in the HAT CPM, and they said that to fulfill that Q-based training requirement, they were familiarizing pilots with the contents of the manual. When we asked a FSDO inspector what had happened with this project, they said that Q-based training in Hawaii was something that seemed to kind of never really come about.
And in fact, there was a lot of movement by FAA until about, I thought I read in the report, until about 2013, and then they shifted responsibility of Q-based training and what it should include and how it should be delivered to the air tour operators themselves, and never really completed anything, correct?
Yes.
Okay, so different question, how could crash-resistant recorders have helped? Not just in this investigation, but identify potential safety issues with Safari or anyone else here?
Well, as you know, we have recommended crash-resistant flight recorders for a number of recommendations. And in this particular case, with the lack of radar, the lack of ADS-B data, the lack of GPS tracking, and our only witness only had audio or could hear the accident, we have no other data to base the circumstances of the accident immediately before. So, and this data is critical in helping us identify areas where we need to improve safety. And it goes through all Part 135 operations as part of our recommendations.
And not just us as the NTSB, but helps operators, correct?
Absolutely, and Dr. Bramble can probably talk about flight data monitoring.
Sure, so having recording devices on aircraft allows an operator to perform a safety assurance. And as far as the crash-resistant recorders, of course, in this case, it would allow us to determine more definitively whether it was controlled flight into terrain or loss of control that occurred in this case. And we'd like to see that level of information being available in future accident investigations.
Great, thank you both. And we're now, unless anyone's changed their mind on additional questions in this part, hearing none, we're going to move on to the second safety issue area, which is company and FAA monitoring of air tour pilot operating practices, and start with Vice Chairman Landsberg.
Thank you, Chair Homendy. So a contributing factor here in the probable cause, which I'm foreshadowing, is the FAA's lack of oversight. And I'd like to explore that a little bit more. The investigators asked questions of the FSDO manager, the Flight Standards District Office. And as I understand it, this is an FAA employee who's responsible for overseeing all flight operations in the Hawaii and kind of Pacific area. That includes air carrier, helicopter, air tour, Part 135, and personal flight operations. And when this person took over the position, it was in 2017. And were there any transition briefings provided by the outgoing manager to the new manager?
No, there were no briefings provided.
Does the FAA have any requirement for that?
The FAA does not have a requirement for transition briefings for managers. However, they do encourage it.
So for air traffic controllers, when they change controllers out on the boards, they are required to have a briefing so everybody has a high level of situational awareness. I would think that would be kind of a critical thing for the FAA to do. Did the inspectors travel regularly to the various tour operators to observe their compliance?
The POI for Safari indicated that he tried to get out quarterly to visit operators.
And
visit each operator a minimum of one time a year.
okay, what I read in the docket was if there were any need to travel requests denied, ostensibly for the inspectors to visit the various operators for compliance reviews, the manager said, well, I don't know. I would have to go back and look. I don't recall, which doesn't give me a lot of confidence that they were right on top of things. It was stated in the report that the Hawaii FSDO was kind of being overworked or overwhelmed, maybe is the proper term, and so they decided to relocate oversight to the mainland. Is that a correct statement?
The Honolulu FSDO had 6 operations inspectors positions. 2 of them were staffed and by fully trained inspectors. 2, they were staffed by inspectors in trainee, and they had 2 vacant openings. They did transfer oversight of some of these certificates to other FSDOs.
So let me see if I understand this correctly. They were essentially almost 70% understaffed, and so in order to make up for it, and they don't have enough money in the budget to provide people who are already in the islands to provide oversight, they're going to move people to other FSDOs, which included what? San Francisco, South Carolina? I mean, this defies any logic whatsoever. Am I correct in my observation?
So the team doesn't feel that it's ideal to have outside the state surveillance, but but it's feasible, and to do at least some kind of surveillance. However, that is why we're recommending that the FAA approach some technology-based, innovative methods of surveillance that would allow them to do more with their limited resources.
Okay. I have some other questions here, Chair, but I'll yield back my time. Thank you.
Great, thank you. Member Graham.
Thank you, Chair Hamady. I'd like to ask some questions about our SMS recommendation history. The NTSB first recommended SMS for Part 135 operators in 2016. Since that recommendation, do you know how many times the NTSB has reiterated that recommendation?
It's been reiterated 6 times.
6 times?
Yes.
So since 2016, that recommendation A1636, has that been included on the NTSB's most wanted list the whole time since then?
I don't know if it's been on the list since it was issued, but it's currently on the current most wanted list.
Yeah, at least the last few years now. Yeah, it's been 6 years this recommendation has been reiterated numerous times. It's on the most wanted list, and the FAA has yet to issue an NPRM, let alone a final rule. For those reasons, this recommendation remains unacceptable. Can you please summarize the FAA's most recent response to recommendation A16-36?
In October 2021, the FAA informed us that it had initiated rulemaking for safety management systems for parts 21, 91, 135, and 145. But as you said, we still haven't seen an NPRM. So.
Haven't seen NPRM. As a matter of fact, for those that are unaware, I think they use the term rulemaking project. So how does that differ from a notice of proposed rulemaking?
My understanding is that it's just the intent to develop or to notify the public that they are in the process of developing the NPRM.
Okay, so it doesn't guarantee that there will be a notice of proposed rulemaking. Is that correct?
I believe that's correct, yes.
Yeah. Should the FAA follow through and issue a notice of proposed rulemaking, does that then guarantee the follow through for the final rule?
No.
No, it does not. Staff proposes, I see here today, reiterating recommendation to A16-36 and maintaining the open, unacceptable status. I agree wholeheartedly with that. Until the FAA issues a final rule requiring safety management systems for all Part 135 operators, the NTSB must maintain that A1636 as open, unacceptable, in my opinion. I'd like to switch to talk a little bit about scalability of SMS. Shortly after we first recommended SMS for Part 135 operators, the FAA established a voluntary SMS program in 2017. Since the voluntary program was established, of the nearly 2,000 Part 135 certificate holders, how many have applied for the program and how many have been accepted?
So as of February 2nd, 2022, 1,940 certificate holders were authorized to conduct 135 operations. 30 have an FAA accepted SMS, and 165 others have applied for FAA acceptance.
Pretty minimal number of operators I see. And I actually spoke to a couple of them at Heli Expo a couple months ago. And they're not the only ones that have said this, that the approval process is very burdensome. Matter of fact, I heard it takes about 3 years to get through the process. Seems pretty long to me. Despite my support for Part 135 SMS rule, I am concerned that the FAA's readiness to oversee SMS compliance for over 2,000 operators and ensure SMS scalability for small operators. How did the president and DO of Safari Aviation respond when asked why they didn't have a full SMS?
He thought they were too small.
Too small, yeah. I see my time's about up. I'll come back to this. Thank you, Chair.
Member Chapman?
Thank you, Chair, and I too have focused on this issue of the very, very small number of operators that currently have FAA-accepted safety management systems under FAA's voluntary program. As Member Graham indicated, nearly 2,000 Part 135 certificate holders. We currently have 30 with approved systems under that, approved SMS systems under that voluntary program. I guess the good news is when we looked at this number about a year ago in the context of another investigation, it was 17. So I guess we could celebrate the fact that they've nearly doubled the number, but I mean 30 out of nearly 2,000. That's a very discouraging statistic, and I wonder if you have an opinion on this. Does FAA have the resources to oversee the development and implementation of safety management systems by such a diverse group of operators, even if there were a rule requiring it?
Well, it certainly would impose a lot of burden on the FSDO offices because the process for approval requires inspectors from those offices to assess and validate the processes that the operator is going to have in place for the SMS. So at a FSDO like the Hawaii FSDO, for example, with 2 operations inspectors already overburdened, where they would find the time to review proposed SMS for 17 air tour operators, for example, that would be a challenge.
Right. Yeah, there's some real challenges in this area. I want to ask a question about Hawaii staffing. I am scratching my head. Is it difficult for FAA to attract people to locate in Hawaii?
The FAA indicated that it was difficult for them to attract people due to high cost of living, the geographic area, things of that nature.
Okay, so is it largely a cost of living issue? Is that, I know a lot of people who would like to spend time in Hawaii. It is a little bit puzzling.
So during interview, we asked the very same questions, and there were several reasons given. There was due to retirement, cost of living, and also other opportunities in flying helicopters elsewhere were the 3 reasons given to us.
Yeah, interesting. I mean, Hawaii is not the only place in the United States where the cost of living is high. I just have to think that there's more to it than maybe we're currently aware. I assume a pilot is less likely to demonstrate, it just seems obvious, a pilot is less likely to demonstrate risky decision-making, such as potentially failing to maintain the 3-mile minimum visibility if a FSDO inspector is making in-person observations. And I imagine there's still a role for this more traditional approach, but I can see that broadening the approach to surveillance might be more likely to detect a drift towards riskier decisions and operating practices. And I gather that's the crux of the draft findings and recommendations we'll consider today. Is that correct? And please feel free to elaborate.
Yeah, so the idea is that having some sort of regulatory presence on a routine basis would discourage risky decision-making, but there are some limitations to the traditional methods. Even if the inspector visits the islands, and maybe even if they go up and do a check ride and try to observe other flights going on at the same time, they can't always be in these remote areas where these pilots are making these decisions. And so that's why we feel like there needs to be some sort of more comprehensive way to see what's going on.
Thank you. I have some additional questions I'll save.
Thank you, Member Chapman. I was reading through the transcripts, and I had a few questions about the head of the FSDO. I was a little bit surprised by the responses to two questions in the transcript, one of which was, I don't know if it was Dr. Bramble or Mr. Banning, if you had asked. The first one was, what do you think would be the most effective strategy for reducing the risk of weather-related air tour accidents in the state of Hawaii? Do you have any ideas in that area? The second of which was, what types of air tour accidents have led to the most fatalities in Hawaii over the last decade or two? I was interested in the response, because the response was, I don't know. I have to look into it more, have to do more research. And this is the head of the FSDO.
Yeah, that was me in that interview. I asked what air tour risks the FSDO had been most focused on monitoring and mitigating in the year before the accident, and she said that she couldn't think of any. And I asked what types of air tour accidents had caused the most fatalities in Hawaii, and she said she couldn't speculate.
Yeah, I mean, that was surprising to me, and I thought very telling. I understand that she is not one of the inspectors, but still, as the head of the office, I thought that was disconcerting. With that said, there were 2 full-time inspectors with 6 positions open, 2 fully trained, 2 who were in training at the time of the accident, correct? So that left, and the staff had said it was a pretty high workload for the office. One thing I was interested in about the office was their update to the Hawaii Air Tour Common Procedures Manual. And you had stated, Mr. Gallo, that the Procedures Manual provides operators in Hawaii with island-specific and site-specific requirements, including minimum altitudes at which tours should enter and exit sites, the reporting points for where pilots must transmit over the radio, the aircraft's call sign and location, and certain altitude limitations. So what was happening with the HAT CPM?
Well, originally, when the current manager, she had the 2 inspectors that were working on that manual, she transferred that work from those inspectors more to stakeholders in the industry, and from that point, it went on to the FAA's air carrier branch, AFS 250. After that, we could never get an estimate of completion or even a proposed replacement of that manual.
So it hasn't been updated since 2008, and what she said, what the FSDO said was they were working on it for some period of time, and then some period of time decided, you know what? These are requirements for the industry that they get from us. These are requirements. And we're just going to turn it over to the industry. They can draft it for themselves, figure out how they should regulate themselves, and submit it for us to look at later. Is that right?
That's correct.
Yeah. You think it's a good idea for the industry to just write their own regulations and that they'll have to comply with and submit that for approval by the FAA?
Well, ultimately, it again got transferred to AFS 250, which is part of the federal FAA. So it was in industry for a while, and then it went to the regulatory branch of the FAA.
And now it's nowhere.
And there's no estimate for completion.
Mm-hmm. Okay, great. Just checking the time real quick. And on inspection resources, well, let's talk for a second on, I just want to ask one last question here on the change in how inspections, in the change of the inspection process over time. It went from an enforcement process to one of more compliance. How has that impacted Hawaii and Hawaii operators, and how has that impacted the FSDO as they've seen a decrease in staffing?
So in 2015-16 timeframe, the FAA shifted to the safety assurance system and more of a risk-based approach to providing surveillance. and a compliance philosophy that was less enforcement-oriented. And what seems to have happened is that resulted in a reduction in sort of routine surveillance that might have previously been going on under the national program guidelines.
And in fact, GAO had said FAA hasn't seen how that's played, hasn't evaluated how their shift in philosophy has played out and how that meets with their mission, correct?
Yes, they found a large drop in enforcement actions by the FAA over several years, but they said that the FAA hadn't evaluated whether or not that was allowing them to meet their goals.
Thank you very much. Vice Chairman Landsberg.
Thank you, Chair Homendy. I'd like to follow up a little bit more on the HAT CPM situation. And in our discussions, we said, even though it's only 15 years since it was committed that they were going to update it, had Safari followed the rules in the previous HAT CPM, we wouldn't be having this conversation. So we had what did the FAA do or not do in terms of updating this HAT CPM? And this may be redundant, but I want to be sure that I fully understand because it's a little discouraging to say the least. Did they do anything?
So it was a little difficult to get a straight answer about exactly what the process was for revising the manual. Apparently they had some meetings with industry. They had sort of a shifting series of responsibilities for who was actually going to be involved in revising the manual. And by the end, it seemed to kind of end up in the lap of somebody in AS350, which is the Part 135 oversight branch at headquarters.
So what I got out of the docket was a question that you asked prior to your taking over as lead. This is to the FSDO manager. And with your subject matter expert in headquarters assisting, do you know who was in charge or who was working on the revision to the HAT CPM? The response was, well, there was no particular person assigned to it, so I immediately did some outreach and spoke to this person and has had interaction with various people through the years, but since 2008, there's not been a point of contact assigned to that project, which to me sounds like word salad. And then the next question was, you asked if this air tour subject matter expert had any helicopter experience in Hawaii. And the response was, I can't answer that. That would be a question for that person. So the manager was responsible for overseeing this project, sloughed it off to the regulatory area, and then said, I have no responsibility for them having any technical background whatsoever in a highly technical area. Am I understanding this correctly?
Yes.
That's a good short answer, thank you. Did the FSDO manager, and this is maybe getting a little hard, but have the ability to lead on such an undertaking? This sounds like a fairly complicated sort of deal on the HAT CPM to include the management skill, the knowledge and resources to deal with this.
The FSDO manager, the Honolulu FSDO manager had a background in cabin safety, which is one of the 5 primary disciplines outlined in FAA Order 8900.1. So she did have a background in cabin safety.
So no operational flight or maintenance experience whatsoever?
That is correct.
This reflects not so much on the FSDO manager, but on the FAA's process of putting people into operationally critical areas and oversight by upper management. This person was set up to fail, in my view. So I take less. Is anybody in Washington, are they paying any attention to this?
I don't know.
Okay. Based on the interviews that we saw in the docket, I find it hard to believe that the FAA can, with a straight face, say that they were effectively overseeing the safety of any and all flight operations in Hawaii. I'll stop here. Thank you.
Great, thank you. Member Graham.
Thank you, Chair. I'll go back to SMS scalability and talking about Safari's size and scope of their operation. I know at the time of the accident, they had 26 employees, 6 pilots, and 4 aircraft. At the board, we've recommended SMS for 135 operations, yet there's a demonstrated hesitancy among small operators, excuse me, who mistakenly believe that an SMS is overly burdensome and not worth the investment to improve safety. We must change that perception. Let's understand a little more how an SMS could have raised the safety bar at Safari Aviation. Excuse me, did Safari Aviation have a flight risk assessment form?
They did not have a risk assessment form, but they had a method for risk assessment, which was to be used for Part 135 operations.
And did they use it for the air tour portion of it?
No, they didn't.
No, they had an opportunity to have some oversight into that, but yet they, basically the president and DO said that the only time they needed it was for the weather, and the pilot flying the air tour out there was the first one to evaluate the weather, and he didn't need to be part of that, which was unfortunate. They had an opportunity there. Let's move into incident reporting, which is critical for hazard identification and risk mitigation. Did Safari require incident reporting?
So we asked that of 2 other pilots within Safari, and they were not familiar with an incident reporting system.
Yeah, the president said that they had one, but none of the employees knew what it was. And employees aren't aware of the company's incident reporting. It's not helping your operation be any safer, I can tell you that. Let's look at safety assurance. A company does not know if their policies and procedures are being followed with without some form of safety assurance. This can take the form of flight data monitoring, or in the case of Safari Aviation, they could have used existing onboard cameras. When the president and DO was asked, when would the chief pilot review onboard cameras, do you remember what his answer was?
He said if perhaps if a helicopter was burning more fuel than expected, they might look to see if a pilot was hot dogging.
Yeah, so that's what he told you guys. The draft report also suggested those at the front desk would periodically review the tapes. What would trigger that review?
The front desk personnel were reviewing the tapes for camera quality, because those tapes would be sold or given to the customers after their flights.
Yeah. Camera quality and occasionally customer complaints. Did I read that?
That's correct.
Yeah, okay. Did those at the front desk have any experience in FAA compliance, company policy, and flight operations?
No, they did not.
No. How could the onboard cameras have supported Safari Aviation safety assurance in ensuring pilots followed its weather minimum policies?
Well, that was a convenient available tool for the company personnel with flight operations experience to review the pilot's decisions under difficult weather conditions.
Did other operators use those cameras for that out there?
Yes, they did.
They did, okay. The president and DO claimed that Safari Aviation could not have implemented an SMS due to the size and scope of its operations, but that they implemented processes as simple as flight risk assessments, incident reporting, and leveraging the existing onboard cameras for safety assurance. Safari Aviation could have laid the foundation for the beginnings of a safety management system. With that, I'll yield back the rest of my time, Chair.
Thank you, Member Chapman.
Thank you, Chair. Chair Homendy discussed this concept of risk-based surveillance. And I'm wondering, at least as the Honolulu FSDO was applying risk-based surveillance, which I understand they did to prioritize their inspector resources, were there any objective standards for determining when greater scrutiny of an operator might be warranted?
So as previously mentioned, the Honolulu FSDO, the FSDO had transitioned to SAS, Safety Assurance System, and the SAS system looks at any number of items that could generate risk, such as previous accidents, incidents, enforcements, surveillance, and that data is fed into the SAS system, and the SAS system generates a risk for an operator.
So that would have been the risk-based surveillance mechanism for determining when greater scrutiny was warranted. But once that determination was made, frankly, the resources weren't there to follow through, correct?
We know that they were short-staffed, yes.
Right. The draft findings and recommendations that we'll consider today focus on the Honolulu FSDO and speak in terms of using technologies and innovative approaches to increase oversight of Hawaii Air Tour operating practices. And that seems to imply, I may not be correct, but that seems to imply that the use of technologies and innovative approaches in surveillance might be a more common practice in other FAA offices. I'd appreciate your comment on that. And if there are such best practices, essentially, being employed in other offices, could those be shared, or are they being shared among other FAA facilities?
This investigation, we looked at the Honolulu FSDO, so we don't have information from other FSDOs.
That's fair enough. That's fair enough. Thank you. I would certainly encourage FAA to do a little bit of an internal inventory if there are FSDOs or other facilities in the field that are doing a particularly good job in this area. Those best practices should be captured, and they should be shared widely, particularly in these areas such as Hawaii, Alaska, other parts of the country where air tours are common. Thank you. That's all the questions I have in this area.
Great, thank you, Member Chapman. A couple of questions. There is a requirement that Safari have an annual, and other operators have annual safety meetings. At some point, at one point, the Honolulu FSDO had led those annual safety meetings. At some point, that was shifted back to the operators to have their own meetings. Can you talk about, and we had talked about this briefly, Mr. Banning, about the difference in how FAA, based on your investigation, participated in these meetings because it was shifted to the operators compared to how the FAA deals with similar meetings in Alaska?
Sure. As you mentioned, in Hawaii, the FAA started by leading these meetings and then moved to more of an advisory role, if you will, in the Hawaii meetings, safety meetings. In Alaska, the FAA's FAST team leads a preseason and a postseason meeting where they look at various risks and provide lessons learned and things of that nature, both in a preseason and a postseason meeting.
So it seems more proactive in the, when you said advisory role for the Honolulu FSDO, mainly answering questions if questions came up in the meeting, as compared to something that's seemingly more proactive in Alaska.
Yes, that's our understanding.
Okay.
Correct.
I want to switch to a second, and this is something Member Graham was focused on with respect to this risk assessment tool. I'm a little bit confused on the purpose of the risk assessment tool that was never used. So in the, I do want to say, the report points out that had the risk assessment tool been used prior to this flight, it would have been low risk. But I think this speaks to really how the operator viewed the responsibility largely on the pilots and not their responsibility to really evaluate risk, identify hazards, and mitigate those risks for pilots and their passengers. The president of Safari Aviation had stated in your questions regarding the risk assessment tool, he said the process of risk analysis is based upon doing charter work that we're not familiar with and or anything else that is not in a normal tour operation. From a tour point of view, risk and management has been done just doing tours from the get-go. If we do something out of the ordinary that is part of the sightseeing tours, then we go through the process of risk analysis of that. What he had said is they use the risk assessment value tool for flights that were out of the ordinary and not for tour flights. Why wouldn't you use a risk assessment tool for all your flights? And what was out of the ordinary compared to a tour flight? And why would there be a different procedure?
Well, that risk assessment value tool is to be done on all flights, tours and charter work, but the very nature of their business was majority done doing air tours.
In fact, their company procedures had said they should use the risk assessment tool for all flights, not just out of the ordinary flights, correct?
That's correct, and they didn't do them for tour flights.
And they just had a procedure outlined in the company manual. It didn't actually have a risk assessment form. There was no form.
There's no form, no documentation.
Okay. All right. Well, it's disconcerting. So I think on this area, I will, you don't have additional questions? You don't have, do you have additional? Okay, we're going to close up this safety issue. We do have an additional safety issue of helicopter safety technologies. Then we have an overarching time where we're going to ask questions on any other portion of the report or investigation. And then we'll move on to proposed findings, probable cause and recommendations. But first, we're going to take a 10-minute break. And so, well, we'll make it 13 minutes. So if we can be back here at 11:40, that would be great. Thank you. All right, we're going to begin with our third major safety issue that we identified in this investigation on helicopter safety technologies, and we will start with Vice Chairman Landsberg.
Thank you, Chair Homendy. So this seems like an obvious question, but I'm going to ask it anyway. Are helicopters harder to fly in instrument meteorological conditions, and if so, why?
Yeah, so the U.S. helicopter safety team talked about this in a recent white paper, and they stated that they are inherently unstable. And unlike fixed-wing aircraft, they don't have the same kind of dynamic stability, and so they can be very difficult to control in IMC.
Okay, so I noticed in the docket that the picture of this aircraft, it had an attitude indicator and a horizontal situation indicator, which would seem to indicate that if somebody knew how to manage it, that was, I guess, instrument qualified, they could in fact keep the helicopter right side up, or is that an unreasonable assumption?
It's possible, but it would be a very high-risk situation because the helicopter is not certificated for flight in IMC, and so it lacks certain features that would normally provide the stability that allows the pilot workload to be manageable in that situation.
Okay. how hard is it to put, say, a basic autopilot on one of these smaller helicopters?
There are a number of commercial providers that offer retrofits now for aircraft, including the AS350. And it is perfectly feasible. You can install a SAS, or you can install a SAS with a 2-axis autopilot. Sorry, SAS is a stability augmentation system.
Okay. Simulation. Are there any relatively low-cost but representative simulators in Hawaii that would be representative of this particular helicopter or some of the other types?
We did not look as far as the simulator availability in Hawaii during the course of the investigation.
Okay. As somebody who has suffered and trained pilots with view-limiting devices, I believe the standard saying is one peak is worth 1,000 cross-checks. And they really don't work very well for really simulating IMC. What's FAA's response been to our request to improve that universal weakness?
Are you referring to A21, 5, and 6?
Well, I guess I might be.
The FAA, in their initial response, they told us that they wanted to meet to go over the intent of the recommendation, and then in the process of scheduling that meeting, they decided that they didn't want to meet. So we haven't really received any substantive information from them as far as what they're doing.
Well, that's sort of par for the course. Would virtual reality headsets be a possibility in this area?
Well, we received some information during the Calabasas investigation that there was development work ongoing for sort of head-mounted augmented reality displays that could provide immersive simulation of IMC conditions in a helicopter.
That would seem to be a very useful kind of a thing, and certainly for these tour helicopters, if they were going to be in a situation where they don't follow their own guidance in the HAT CPM, maybe FAA ought to be really encouraging that kind of training. So I have no further questions, Chair. Thank you.
Great, Member Graham.
All right. Sorry about that. This was a single-engine helicopter, is that correct?
Yes.
Okay. How many IFR-certified single-engine helicopters are there in the U.S.?
I'm only aware of one.
Yeah, me too. Matter of fact, I learned of that one last year during our Calabasas board meeting accident.
Actually, Member Graham, in 2019, 2 manufacturers certified 2 different single-engine IFR helicopters.
Okay, so there's more than one. I knew there were some in work. I'm looking at the adverse weather encounter procedures here out of Safari's operations manual. And there's procedures in there for getting out of the weather if you go in and invert an IMC. The first and foremost thing is to get on the instruments, is that correct? For any inadvertent IMC condition?
That's correct.
That's correct. Well, if you're not an instrument certified pilot or have experience in it, how are you supposed to get on the instruments if you're not trained in it, you're not current, and you're not proficient?
There's a certain level of training and checking under Part 135 for emergency situations for flight into IMC.
Okay. And do they do that in the airplane, or do they do that in a simulator?
That was done in a helicopter.
Okay. And can you explain how they do that? How do they simulate IMC in a helicopter?
They'll use a view-limiting device.
Okay. Something like this, close around so you can only look at the instrument panel?
That's correct.
Okay. I see a problem with that because there's windows on the floor on each side of the helicopter. So I would assume the pilot, if he wasn't cheating, he wasn't trying very hard. He could probably get a good reference to the ground by looking out the windows on the side, could he not?
That's possible, and you could also inadvertently look outside, too.
Okay. Yeah, I look at these procedures here, and, they're not, I don't think these are very appropriate, especially for if you're flying in a canyon, like Waimea Canyon, and you go IMC, they have you doing all this stuff before getting away from the rising terrain. Well, you're in a canyon, I think you'd want to get away from the rising terrain immediately. I look at the same thing that we did when we did Calabasas last year. The 4 Cs, control, climb, course, communicate. Well, I don't think this pilot or the pilot of Calabasas did any of that. So what's the answer here? In your opinion, what's the team's answer to somebody going inadvertent IMC? How do we train a VFR-only pilot to survive in a situation like this, other than don't get near the weather in the first place?
Well, the first step is to have more forgiving equipment. We think more automation might make a temporary encounter more survivable, but then once they have that equipment, they need to develop some training that's compatible with its capability. And that's got to include avoiding terrain and maintaining control of the helicopter.
I think simulation is probably the way to go, because you got to get them out of the airplane. The airplane's not a good place to simulate this. I think the fixed wing community has definitely learned this over the years. We do our full type ratings in the simulator anymore in IMC conditions. So I have no further questions. Thank you.
Member Chapman.
Thank you, Chair. Just a couple of questions in this area. The technologies we're talking about focus primarily on preventing in-flight loss of control. How widely adopted are these technologies currently among the user community generally, and certainly among the air tour operating community?
Not very widely adopted, and that's why we would like to see more awareness put out there for the operators and the air tour operators in particular about options that are available to them, so that they can perhaps voluntarily incorporate some of these technologies into their fleets.
And are these technologies becoming, I'm sure there's a cost involved. Is the cost improving as the technology improves and as it becomes more widely available?
Yes, and well, let's start with the cost. So there is a, Genesis, for example, makes a SAS system that you can retrofit on an AS350, and the cost is about $60,000. And for another $10,000, they can incorporate a 2-axis autopilot. That's about 5% of the cost of a used AS350 B2.
Thank you. Question about the Vertical Aviation Safety Team, or VAST. Tell us about this. What is it and how does it function?
So VAST is an international organization dedicated to promoting the safety of helicopters and multi-rotor aircraft. And it was formed in 2020, and it includes participation by the FAA and the European Aviation Safety Agency, and also many of the major manufacturers of helicopters, and also advanced air mobility vehicles. And one of the projects that they are planning to work on is this Safety Star rating system for helicopters, sort of modeled after the National Highway Traffic Safety Administration's Safety Star rating system. The idea is to create consumer-driven demand for some of these technologies that may not necessarily be required. And so they're in the process of beginning that work.
And we see this as one of the mechanisms, not the only one, but one of the mechanisms that could essentially help spread the word in terms of these technologies.
Yes, and the FAA also in the past has used their rotorcraft safety promotion concept to put information out there through special airworthiness information bulletins that talk about which aircraft have certain safety features and what retrofits are available. They've used that for crash-worthy fuel systems, and also for bird strike prevention technologies. And they've reported to us that they've received some enthusiastic responses from operators learning about which helicopters do and don't have some of these features and what some of their retrofit options might be.
Great, thank you, that's helpful. No further questions in this area for me, Chair.
Thank you. All my questions were asked. I would just make one comment that I agree with something that Member Graham said about simulators. Recently, I was in New York City and visited the Staten Island ferry, which had been involved in a couple of accidents that we investigated, and they had implemented or installed a pretty comprehensive simulator, which introduced different weather for those who were on the simulator and different types of operations. So it was fantastic, and I do agree that that is something that I'm happy that we are reiterating that recommendation, but hopeful that it will move forward. So hearing that there are no other questions in this area, I would open it up for any other questions related to the report. None? I do have two, and these two questions aren't necessarily related to the report, but one for Mr. LeBaron. And why is the NTSB needed? What do we bring to the table? Why should we conduct oversight of other federal agencies like the FAA or other DOT agencies, or even outside the DOT, sometimes when we issue recommendations to other federal agencies?
Well, here I thought I was going to escape and not get any questions, so thank you for the question. I really think this goes back to the founders of our agency. And if you stop and think about the Safety Board Act of 1974 and some of the things that were discussed during that hearing, and one particular congressperson in that hearing had made the statement that said, in the committee's view, no federal agency can perform properly such investigatory functions unless it's totally separate and independent from all other agencies. And then went on to say that only an independent agency can be expected to be unbiased in the oversight role. So when I think of that particular, those two statements alone, the regulator cannot be expected to be unbiased in oversight. And so I believe the founders of our agency specifically had that in mind when they developed and they established the National Transportation Safety Board, that we needed to be an independent, unbiased, non-political agency for that oversight.
That's exactly right, our core value of independence. And recently there has been some discussion about our authority, our long-standing authority on commercial space and other areas. We have no stake in the game. We are the ones that are able to look at what would prevent a similar accident from occurring again, and to look at what needs to change, whether it's an action by the regulator or an action of the operator or the community at large. And so I appreciate that answer. And I'd ask one other question, Ms. Catania. After I started this meeting by saying the first step in this process is really this report, the conclusion of the investigation, the issuance of a final report. But that's not the end of our work. And can you talk about that?
Sure thing. And we do many things after the board meeting. The Office of Safety Recommendations and Communications works with staff and board members to drive action on implementing our recommendations. We do this in many ways, including recording and tracking the status of responses to all NTSB recommendations. We meet with recipients and ensure understanding of what we ask. We evaluate actions and inactions and draft letters to recipients explaining our evaluations and how to meet our recommendations. We educate Congress, governors, state legislators about our recommendations, and we also monitor federal and state legislative efforts to improve safety. We engage with industry, government, and the public through media engagements and roundtable discussions and external stakeholder collaborations. And we develop advocacy campaigns to call attention to our safety recs, which promote in various ways, including webinars, blogs, podcasts, and social media. And this includes advocating, of course, for our safety items on the most wanted list, which includes 2 issues that played a role in this investigation: require and verify the effectiveness of safety management systems in all revenue passenger carrying aviation operations, and install crash-resistant recorders and establish flight data monitoring programs. So, thank you.
Thank you very much. And with that, I'm going to ask Mr. Curtis to read our findings as proposed.
Certainly, Chair. As a result of this investigation, staff proposes 20 findings. Number 1, none of the following safety issues were identified for the accident flight. 1, pilot qualification deficiencies or impairment due to medical condition, alcohol, other drugs, or fatigue. 2, helicopter malfunction or failure. Or 3, pressure on the pilot from other Safari Aviation Inc. managers to complete the flight. Number 2, the accident pilot continued the tour flight into an area of deteriorating weather until he encountered instrument meteorological conditions and lost adequate visual references. Number 3, due to the lack of information about the helicopter's flight track or any other parameters, it could not be determined whether the accident pilot maintained controlled flight after encountering instrument meteorological conditions or lost control of the helicopter before it struck terrain. Number 4, the pilot's decision to continue the flight into deteriorating visibility was likely influenced by a lack of relevant weather information and an atypical weather pattern, and may have been influenced by the possibilities that he inadequately assessed the weather conditions in flight or was overconfident in his abilities. Number 5, considering that at least 3 other tour flights entered reduced visibility conditions on the day of the accident, it is possible that procedural drift towards risky weather-related operating practices existed among pilots of the local air tour community. Number 6, as a result of the Federal Aviation Administration's FAA lack of leadership and expert guidance in developing queue-based weather training for air tour operators in Hawaii, Safari Aviation Inc.'s pilot training program, which was approved by the Honolulu Flight Standards District Office, did not provide Safari's pilots with a type of training that the FAA's queue-based training research determined was effective for improving pilots' skills for accurately assessing and avoiding hazardous in-flight weather conditions. Number 7, although Safari Aviation Inc. had a policy that defined company expectations for pilot adherence to minimum weather requirements, it did not have adequate safety assurance processes to assess whether company strategies to reduce pilots' risk of inadvertent encounters with instrument meteorological conditions were effective. Number 8, the Federal Aviation Administration's full implementation of a Hawaii weather camera system as planned will provide access to continuously update weather imagery that will support pilots' weather avoidance, decision-making, and likely reducing weather-related air tour accidents in the state. Number 9, now that the first aviation weather cameras are operational in Hawaii, the ability for en route pilots to obtain essential information from ground support personnel, such as flight service station specialists, based on the camera's imagery is particularly relevant due to the rapidly changing weather conditions on the islands. Number 10, improved air-to-ground radio communications capability between the pilots of low-flying air tour flights in Hawaii and ground support personnel, such as flight service station specialists and company flight support personnel can enhance the safety of air tour operations. Number 11, the automatic dependent surveillance broadcast, ADSB, infrastructure in Hawaii is insufficient to adequately enable ADSB out and in supported services such as real-time flight position tracking and onboard traffic advisories that are essential for the safety of low-flying air tour aircraft throughout their entire tour routes. Number 12, air tour pilots would benefit from real-time decision-making support from trained company flight support personnel who have operational control authority, continuous access to updated weather information, and the ability to actively monitor the progress of the flights and communicate with pilots en route. Number 13, the safety of all air tour operations, regardless of size, would be enhanced by the implementation of a safety management system. Number 14, a flight data monitoring program which can enable an operator to identify and mitigate factors that may influence pilots' deviations from safe operating procedures can be particularly beneficial for operators like Safari Aviation Inc. that conduct single pilot operations and have little opportunity to directly observe their pilots. Number 15, the recording and routine review of onboard videos and automatic dependent surveillance broadcast data by air tour operators, ideally as part of a safety management system with an integrated flight data monitoring program, could enable them to, 1, identify instances where pilots encountered reduced visibility, weather conditions, or descended below Federal Aviation Administrative required minimum altitudes. 2, perform non-punitive examinations of these events to determine whether they resulted from encounters or near encounters with instrument meteorological conditions, IMC, and to learn about IMC-related hazards. And 3, evaluate the effectiveness of existing risk controls to prevent their pilots from drifting into risky weather-related operating practices. Number 16, the use of technologies and innovative approaches can help the Honolulu Flight Standards District Office provide increased oversight of Hawaii air tour operating practices, which could decrease the likelihood of a drift toward risky operating practices by local air tour operators and their pilots. These approaches may include, but are not limited to, comparing automatic dependent surveillance broadcast flight position data from air tour flights with weather camera imagery for the route and periodically reviewing onboard video recordings to monitor pilots' weather-related decision-making during tours. Number 17, if all commercial air tour aircraft were required to be equipped with crash-resistant recording systems that capture images, flight deck audio, and flight data, improved information about accident circumstances would permit more definitive evaluation of the causes of fatal air tour accidents and identification of more effective measures to prevent these accidents. Number 18, although Airbus helicopters had developed and issued service bulletins for the voluntary retrofit of crash-resistant recording systems on Airbus AS350 helicopters, more than 2 years before the accident, Safari Aviation Inc. had not installed such recorders in the accident helicopter or any other helicopter in its fleet. Number 19, increased voluntary adoption of helicopter safety technologies designed to help reduce accidents resulting from inadvertent encounters with instrument meteorological conditions can help save lives. And number 20, the use of simulation technologies in helicopter pilot training has the potential to help reduce accidents involving the inadvertent encounters with instrument meteorological conditions by enhancing the weather-related decision-making and assessment aspect of scenario-based training and providing opportunities for pilots to develop skills to detect and recover from vestibular illusions that could lead to spatial disorientation. Chair?
Thank you. Are there any amendments to the findings as proposed? Hearing none, is there a motion to adopt the findings as proposed?
So moved.
Moved by Vice Chairman Landsberg. Is there a second?
Second.
The motion has been seconded by, I'll go with Member Graham. Council will call the roll and tally the vote.
Board members, if in favor, say aye. If opposed, say nay. Vice Chairman Landsberg.
Aye.
Member Graham. Aye. Member Chapman.
Aye.
Chair Homendy.
Aye.
Chair, the vote tally is 4 votes in favor of adopting the findings as proposed.
Thank you. Findings are adopted as proposed. And Mr. Curtis, will you read the probable cause as proposed?
Staff proposes the following probable cause. The NTSB determines that the probable cause of this accident was the pilot's decision to continue flight under Visual Flight Rules, VFR, into Instrument Meteorological Conditions, IMC, which resulted in the collision into terrain. Contributing to the accident was Safari Aviation Inc.'s lack of safety management processes to identify hazards and mitigate the risks associated with factors that influence pilots to continue VFR flight into IMC. Also contributing to the accident was the Federal Aviation Administration's delayed implementation of a Hawaii Aviation Weather Camera Program, its lack of leadership in the development of a Q-based weather training program for Hawaii Air Tour pilots, and its ineffective monitoring and oversight of Hawaii Air Tour operators' weather-related operating practices.
Thank you,
Chair.
Mr. Curtis. Are there any amendments to the proposed probable cause? No? Is there a motion to adopt the probable cause? Is there a second?
Second.
Thank you. And council will call the roll and tally the vote.
Those in favor of adopting the probable cause will vote aye. Those opposed will vote nay. Vice Chairman Landsberg.
Aye.
Member Graham. Aye. Member Chapman.
Aye.
Chair Homendy.
Aye.
Chair, the vote tally is 4 votes in favor of adopting the probable cause as proposed.
Thank you. The probable cause has been adopted as proposed. And Mr. Curtis, will you read the proposed safety recommendations?
As a result of this investigation, staff proposes 10 new safety recommendations, 8 to the Federal Aviation Administration. Number 1, install the necessary infrastructure in Hawaii to enable continuous radio communication between the pilots of low-flying tour flights and ground support personnel, such as flight service station specialists and company flight support personnel along the most heavily trafficked air tour routes. Number 2, implement automatic dependent surveillance broadcast, ADSB, infrastructure improvements in Hawaii, such as additional ADSB ground stations that provide adequate coverage to enable real-time flight tracking and traffic advisory services for ADSB out and in equipped low-flying air tour aircraft throughout their entire tour routes. Number 3, as an interim measure until completion of the action to satisfy Safety Recommendation A2115, require Hawaii Air Tour operators to install automatic dependent surveillance broadcast out equipment in their aircraft to enable real-time flight position tracking. Number 4, require Air Tour operators to have flight support personnel who are trained to exercise operational control authority, participate in pre-flight risk analysis, provide pilots with weather briefings, monitor the progress of the flights, and participate in two-way communications with pilots to alert them of any weather hazards. Number 5, develop guidance for small operators for scaling a safety management system that includes methods and techniques for implementation and specific examples applicable to several operational sectors, including air tours. Number 6, issue a safety alert for operators to encourage air tour operators to establish safety assurance processes to routinely review recorded onboard videos and automatic dependent surveillance broadcast flight tracking data, ideally as part of a safety management system with an integrated flight data monitoring program for the purpose of identifying and addressing risky trends and weather-related operating practices, such as encounters or near encounters with instrument meteorological conditions-related hazards. Number 7, improve the surveillance of air tour operations in Hawaii through the use of technologies and innovative approaches, including but not limited to comparing automatic dependent surveillance broadcast flight position data from air tour flights with weather camera imagery for the route and periodically reviewing onboard video recordings to detect and correct operating practices that may lead to unacceptable weather-related risky behavior. Number 8, issue and periodically update a special airworthiness information bulletin that lists newly manufactured helicopters that are equipped with features likely to reduce accidents resulting from inadvertent encounters with instrument meteorological conditions, describes retrofit options for helicopters that do not have such equipment, and encourages the voluntary integration of these safety features. One recommendation to Vertical Aviation Safety Team, number 9, include in your proposed helicopter safety rating system helicopter safety features for preventing accidents resulting from inadvertent encounters with instrument meteorological conditions. And one recommendation to tour operators program of safety, number 10, inform your members and make information available to the broader air tour community about the circumstances of this accident, provide information about available helicopter safety technologies for reducing the risk of accidents related to inadvertent encounters with instrument meteorological conditions, and encourage air tour operators to voluntarily incorporate such features into their helicopter fleets. Staff proposes reiterating 9 previously issued recommendations in this report, all to the Federal Aviation Administration. Number 1, recommendation A1313, require all existing turbine-powered, non-experimental, non-restricted category aircraft that are not equipped with a flight data recorder or cockpit voice recorder and are operating under 14 Code of Federal Regulations, Parts 91, 121, or 135, to be retrofitted with a crash-resistant flight recorder system. The crash-resistant flight recorder system should record cockpit audio and images with a view of the cockpit environment to include as much of the outside view as possible, and parametric data per aircraft and system installation, all as specified in Technical Standard Order C197, Information Collection and Monitoring Systems. Number 2, recommendation A1325, initiate an aviation weather camera program in Hawaii that includes the installation and maintenance of aviation weather cameras at critical locations in Hawaii. Establish public access to these aviation weather cameras' real-time imagery. Number 3, recommendation A1327, equip flight service station specialists responsible for Hawaii and the continental United States with the technical capabilities and training to provide verbal, pre-flight, and en route briefings using aviation weather camera imagery. Number 4, recommendation A1634, require all 14 Code of Federal Regulations, Part 135 operators to install flight data recording devices capable of supporting a flight data monitoring program. Number 5, recommendation A1635. After the action and safety recommendation A1634 is completed, require all 14 Code of Federal Regulations, Part 135 operators to establish a structured flight data monitoring program that reviews all available data sources to identify deviations from established norms and procedures and other potential safety issues. Number 6, recommendation A1636. Require all 14 Code of Federal Regulations, Part 135 operators to establish safety management system programs. Number 7, recommendation A2115. Identify high-traffic air tour areas and require, through a special federal aviation regulation or other means, that Title 14 Code of Federal Regulations, Parts 91 and 135 air tour operators that operate within those areas be equipped with an automatic dependent surveillance broadcast out and in supported traffic advisory system that 1, includes both visual and oral alerts, 2, is driven by an algorithm designed to minimize nuisance alarms, and 3, is operational during all flight operations. Number 8, recommendation A215. Require the use of appropriate simulation devices during initial and recurrent pilot training for Title 14 Code of Federal Regulations, Part 135 helicopter operations to provide scenario-based training that addresses the decision-making, skills, and procedures needed to recognize and respond to changing weather conditions in flight, identify and apply mitigation strategies for avoiding adverse weather, practice the transition to the use of flight instruments to reduce the risk of spatial disorientation, and maintain awareness of a variety of influences that can adversely affect pilot decision-making. Number 9, recommendation A216. Convene a multidisciplinary panel of aircraft performance, human factors, and aircraft operations specialists to evaluate spatial disorientation simulation technologies to determine which applications are most effective for training pilots to recognize the onset of a spatial disorientation and successfully mitigate it, and make public a report on the committee's findings. And finally, staff proposes classifying and reiterating 2 previously issued recommendations in this report, both to the Federal Aviation Administration. Number 1, recommendation A718. In cooperation with Hawaii commercial air tour operators, aviation psychologists, and meteorologists, among others, develop a Q-based training program for commercial air tour pilots in Hawaii that specifically addresses hazardous aspects of local weather phenomena and in-flight decision-making. Safety recommendation A718 is classified open, unacceptable action in section 2.3.2 of this report. And recommendation A719. Once a Q-based training program that specifically addresses hazardous aspects of local weather phenomena and weather-related decision-making issues is developed, as requested in safety recommendation A718, require all commercial air tour operators in Hawaii to provide this training to newly hired pilots. Safety recommendation A719 is classified open, unacceptable action in section 2.3.2 of this report. Chair.
Thank you, Mr. Curtis. Are there any amendments to the recommendations as proposed? No amendments. Is there a motion to adopt the recommendations as proposed?
So moved.
Second.
Moved and seconded. Council, can you call the roll and tally the vote?
Those in favor of adopting the recommendations will vote aye. Those opposed will vote nay. Vice Chairman Landsberg.
Aye.
Member Graham. Aye. Member Chapman.
Aye.
Chair Hamady.
Aye.
Chair, the vote tally is 4 votes in favor of adopting the recommendations as proposed.
Recommendations as proposed has been adopted. Are there any amendments to the final report? No. Is there a motion to adopt the final report?
So moved.
Is there a second? Second by Member Graham. And Council, can you call the roll and tally the vote?
Those in favor of adopting the report will vote aye. Those opposed will vote nay. Vice Chairman Landsberg.
Aye.
Member Graham. Aye. Member Chapman.
Aye.
Chair Hamady.
Aye.
Chair, the vote tally is 4 votes in favor of adopting the report as proposed.
Final report is adopted. And does any member reserve the right to file a concurring or dissenting statement?
I would like to.
Vice Chairman Landsberg? I'd like to reserve the right as well. And with that, Our deliberations have now concluded. I thank my fellow board members for their preparation and participation in today's meeting. We discussed important topics that will benefit the final report and inform our safety recommendations. Fact is, this tragedy should never have occurred. It was 100% preventable. Since 1997, the NTSB has investigated 282 air tour accidents nationwide, 61 of which were fatal. We've investigated 41 air tour accidents in Hawaii, including this one, 15 of which were fatal. Of those 41 accidents, 9 involved a pilot's decision to continue a visual flight rules flight into deteriorating weather. Those 9 accidents resulted in 51 deaths. 51 deaths that were preventable. Some watching might feel this was all on the pilot. It was, after all, his decision to continue flight under VFR and to instrument meteorological conditions, and pilots operating under VFR must take appropriate action to avoid weather hazards, including knowing when not to fly, when to divert, or when to land. But I want to draw attention to something Safari's president said, which I think is telling. Pilots are the only ones who can assess whether to continue, divert, return, or cancel a flight, because the pilot is the only one who sees what the weather is like. That is what Safari Aviation stated. But others should be able to help the pilot. There are infrastructure, equipment, safety technologies, and training that can assist pilots to help ensure safe flights, and that's where the operator, Safari Aviation, and the regulator, the Federal Aviation Administration, comes in. I'm pleased that Safari took action to implement ADSB out and in equipment on all 3 of its helicopters, but it also needs to take immediate action to develop and implement a comprehensive safety management system to identify hazards such as weather and mitigate the risk to their pilots and their passengers, and a flight data monitoring program to help pilots, instructors, and operators improve performance and safety. But most concerning to me is the lack of leadership, safety action, and oversight provided by the regulator, which is charged by law with assigning and maintaining safety as the highest priority in air commerce. Assigning and maintaining safety as the highest priority in air commerce. The NTSB has issued recommendation after recommendation to the FAA following accident after accident, which would have, if implemented, prevented the deaths of the 4 adults and 3 children, the youngest of which was just 10 years old, who died in this tragedy. In fact, in this report, we reiterated 11 recommendations that we've made to the FAA before, 11 recommendations. We recommended crash-resistant flight data recorders and cockpit voice recorders in 2013, 2014, 2 times in 2017, 2018, 2020, 2021, and now again in 2022. In 2016, we asked the FAA to require Part 135 operations to establish a safety management system. We asked them again in 2017, 2018, 2019, 2020, and 2 times in 2021. Starting in 2009, 12 years ago, we recommended that the FAA require helicopter air ambulance operators to establish a structured flight data monitoring program and install recording devices capable of supporting it. In response, the FAA required such operators to equip their fleet with recording devices, but did not require them to establish an FDM program. In 2016, we expanded our FDM recommendations to FAA to all Part 135 operators and reiterated it in 2018, 2019, 2020, and 2021. FAA's response was disconcerting, at best. The regulatory evaluation for just the helicopter air ambulance final rule showed FDM costs of approximately $20.4 million over a 10-year period and benefits of zero. Zero. Explain that to the families and friends who've lost loved ones in the tragedies that we've investigated. The recommendation is now classified as open unacceptable response, and SMS, crash-resistant recorders, and flight data monitoring continues to be among our most wanted list of transportation safety improvements. In 2007, we recommended that the FAA develop queue-based training
programs for for Hawaii pilots so that they can address hazardous local weather phenomena and make informed in-flight decisions. In 2008 and again in 2019, the FAA informed us that it was shifting responsibility for developing Q-based weather training to Hawaii Air Tour operators without providing leadership or expert guidance on what the training should include or how it should be delivered. As a result, and as stated in this report, the accident pilot did not receive the type of training that FAA's own research has shown can improve the accuracy of pilots' in-flight weather assessments and increase the likelihood of a prompt diversion in deteriorating weather conditions. Had the accident pilot made a timely decision to divert, this accident may have been avoided. We have also continually suggested actions that the FAA can take to improve safety in air tour operations. This includes implementing ADS-B equipment in Hawaii. We made a recommendation in 2007 to the FAA to require air tours to install ADS-B out and in on their aircraft. But the FAA decided to try and encourage voluntary installation rather than require operators to install this important safety equipment. Since that time, we've conducted a number of investigations that have shown the benefits of ADS-B. So we're again making a recommendation to the FAA about having air tour operations in Hawaii install and utilize ADS-B. The same can be said for weather cameras. In 2013, we called on the FAA to develop a weather camera program in Hawaii, which has been a tremendous success in Alaska. I understand that the FAA has made progress in this area, installing cameras in 2 locations of Kauai, but not the accident location, and they still have a long way to go. Locally, there was minimal FAA oversight of the safety of air tour operations in Hawaii, particularly with respect to the kinds of decisions pilots were actually making during tour flights. The FSDO was understaffed, and as described by inspectors, had an extremely high workload. There were 6 inspector positions available, only 2 were filled with fully trained inspectors at the time of the accident, despite the presence of 17 helicopter air tour operators in Hawaii. At the same time, the FAA had transitioned to more of a risk-based approach to oversight versus an enforcement program, which according to the GAO, the FAA has not evaluated to determine whether it supports the FAA's mission. Our investigation also found that the Hawaii Air Tour Common Procedures Manual has not been updated since 2008. As stated in the board meeting, this manual provides operators in Hawaii with island-specific and site-specific requirements. The FAA started to revise the manual, but around 2018, they transitioned the authority for the revisions to the very industry they are charged with regulating, the air tour industry. Additionally, the safety meetings that brought the industry and the FAA together had been organized by the FAA, but over time they began to decrease their involvement and began to shift responsibility of these meetings to the air tour operators. The fact is, the FAA should be leading on safety, not ceding their responsibility to the industry that they are charged with regulating and overseeing. We know that the FAA is not providing the necessary leadership because accidents like this continue to happen. We at the NTSB have made safety recommendations to address the issues that continue to contribute to these accidents, and the FAA needs to act on our safety recommendations now to ensure the safety of pilots and their passengers. In closing, I'd like to extend the board's gratitude to our colleagues in the Office of Aviation Safety, the Office of Research and Engineering, and the Office of General Counsel for their work over the course of the investigation and in the development of this excellent report. It is you all who are out there each and every time there is an accident, and it has to be extremely difficult to continue to see the same issues that are preventable had our recommendations been implemented. I can tell you that all of us up here greatly appreciate your work. Thank you very much for all you do. The board also extends its appreciation to our colleagues in the Office of Administration, the Office of the Chief Information Officer, and the Digital Services Division, who did provide some web support for this meeting, so thank you very much, and continuing with our showing of the findings, recommendations, and the probable cause to those who can see it on screen. As I mentioned earlier, this is the first in-person meeting of the board since February 2020, and I can't tell you how much it is nice to be back together as a group to deliberate an accident, even given the tragedy. Finally, I'd like to thank the Office of Safety Recommendations and Communications for its diligent work and advocacy to improve safety. When acted upon, the recommendations we've issued and reiterated today will save lives. The NTSB looks forward to working with the FAA, the Vertical Aviation Safety Team, and the Tour Operators Program of Safety to implement our recommendations. At the same time, NTSB will not stop working to create a safe transportation system where there's no longer a need for our recommendations. Thank you. We stand adjourned.